Hello and welcome to the best video on atomic bombs. I made this video to give you a brief description about the bomb and its origin, so you're welcome. So what is an atomic bomb? I could just say it's a big bomb, but I probably won't get a good grade if I did. So I'm going to get a little sciencey here in a moment, so just try to live through it, alright? Before I talk about the bomb itself, I'm going to tell you what causes such a great explosion. So let's go back in time to 1938, where Otto Hahn and his assistant Fritz first discovered the nuclear fission of heavy elements. Okay, nuclear fission basically is the process in which the nucleus of an atom is split into smaller parts, or you could just say the splitting of the atom. Anyway, right after the split, a very large amount of energy is released, which you should know as this. Okay, next we have the origin of the atomic bomb. Before the atomic bomb, we humans just use conventional bombs like this M117, which causes its destruction in the form of a blast using materials like TNT or etc. But now with atomic bombs, we use an unstable isotope from either a uranium or a plutonium atom. But first, scientists had to create a design so a neutron could be shot at one of the two unstable atoms, causing it to split and shoot out more neutrons that goes on to split even more atoms, causing a chain reaction which all occurs in about 1 picosecond, by the way. On August 2nd, 1939, right before the beginning of World War II, Albert Einstein wrote to the president telling him of efforts in Nazi Germany to purify uranium-235, which could be used to build the first atomic bomb. It was shortly thereafter that the United States government began a serious undertaking known as the Manhattan Project. Basically, it's just a gathering of the smartest scientists from the US, the UK, and Canada who all came together in efforts of making the first atom bombs for the Germans. Of course, they figured out they had to split a very unstable atom like uranium, but the thing is, at the time, no ordinary chemical extract could separate uranium or an atom like it. Only mechanical methods could do this. So the first step was to increase the atom's instability so it would be easier to split the atom and at the same time cause more destruction. Then the atom has to go through magnetic separation, then gas centrifuge is used. Both methods actually help separate the isotope. Basically, that was it. The only thing that was left was to see if nuclear fission actually worked. I know the process doesn't sound like much, but you have to remember, over the course of 6 years, from 1939 to 1945, over $2 billion were spent towards the Manhattan Project. In today's money, that's $23,682,804,542.07. Now that's enough money to buy you 339,000 male baby zebras, if you're into that kind of stuff. The first bomb out of 4 was tested at 5:29 Mountain Wartime on July 16, 1945. The brilliant light from the detonation pierced the early morning skies with such an intensity that the residents from a faraway neighboring community would swear that the sun came out twice that day. Even more astonishing, it was said that a blind girl saw the flash 120 miles away. Here's a fun fact. Everybody knows about the bombing in Hiroshima and Nagasaki on August 6, 1945 during World War II. But did you know that the bombs used had 2 completely different designs? Little Boy was a gun type assemble weapon and was the bomb dropped on Hiroshima. It used about 141 pounds of uranium with an average enrichment around 80%. The uranium-235 was formed into 2 subcritical pieces, one of which was later fired down a barrel to join the other piece, which caused the explosion. The Fat Man was an implosion-type weapon and was the bomb dropped on Nagasaki. The Fat Man device specifically used 13.6 pounds of plutonium-239. The plutonium core was put in the center of the bomb shell around a neutron initiator and then was squeezed by a temper, which caused the explosion. But these were just early models. Later on, scientists went on to make other types of nuclear weapons like fusion-boosted fission weapons, 2-stage thermonuclear weapons, hydrogen bombs, clean bombs, cobalt, and neutron bombs. With all the research I did on these nuclear weapons, I now have respect to all the people who participated in this field of science, because to me this was some really, really, really complicated stuff, and because I think no matter how much science you put into it, at the end of the day, a bomb is still a bomb. Thanks for watching.